Dear students, welcome to the course of Basic Genetics, and we are discussing in this unit about the human genetics and analysis of the pedigree. So, you all have already learned how the autosomal inheritance takes place, and today I am going to talk to you about the sex-linked inheritance. What are different types of inheritance pattern that is linked with the sex chromosomes. So, the trait that are determined by the genes that are located on sex chromosomes, they are mostly the traits that are showing the X-linked or Y-linked inheritance pattern. And as you remember that the autosomal disorder that I have discussed, right, I did discuss about the recessive type of inheritance and dominant type of inheritance. Same is true here. When we are talking about X chromosome especially, we do see the X-linked recessive inheritance, we see X-linked dominant inheritance. And in case of Y chromosome, you know that only male is having the Y chromosome. So there is only one copy of Y chromosome present anyways. So Y chromosome does not fall in the classification of dominant and recessive. Whatever the genes are there, they most of the time manifest their effect, except a few which fall in the pseudo-autosomal region, which is at least beyond the scope of this unit. So let's take a look at three different type of inheritance patterns that I have just mentioned with you one by one. So first we will talk about the identification of X-linked recessive inheritance, right? So how the recessive traits are going from one generation to another, and how by looking at pedigree we can determine. So always remember what I am trying to do, and I hope that you are able to follow the points that I am taking individual pedigree. I show that how by looking at the pattern of inheritance and also by then placing the prospective genotype, assigning the genotype to individuals in the pedigree, we can ascertain that this is this type of inheritance. Also remember that sometimes when you just look at the pedigree, it might be difficult for you to conclude. And so take it easy, don't worry about it too much. Just try to get to the conclusion in a correct and logical way. But if a pedigree is not having enough data, sometimes you also might find that you cannot rule out of the two possibility. So we will discuss this kind of thing in our next class in more detail when I'll take quite a few examples one by one. But in this class, I will be focusing on the X-linked dominant and recessive, and then Y-linked characters with the pedigree example, so that you can easily follow that. So now, as you have seen before, every type of inheritance pattern has a pattern. Like there are certain things that you see more often than the others. So like in case of X-linked recessive inheritance, more males are affected than female. Remember that. So one thing I'm pointing out here, and I'll help you understand in the next class, sometimes both the recessive inheritance mean autosomal recessive and X-linked recessive, or autosomal dominant and X-linked dominant. They cut very close to each other. And so you need to focus on some critical parameters that are different between the two pedigree. And that is why I made these two first points extra bold, so that you can see that these are more important and discriminatory. So in X-linked recessive inheritance, more males are affected than female. Whereas in the autosomal disorders, the male and female inheritance pattern was not affected. You would see equal amount of male and female mostly in those cases. But in this case, you will see more males are affected. You also see that affected males often have carrier mothers. So carrier mothers mean that they might, because they have two X chromosomes, they themselves are not affected, but they are those that are transferring that character to the next generation. These characters also skip generation. You have seen it in autosomal recessive case too. Here, no male to male transmission. So this is also one of the discriminatory feature, 1, 2 and 3 from autosomal. So no male to male transcription, whereas in autosomal cases you would see a unbiased transmission to male as well as female. All daughters of affected males are carrier, right? So these are 5 important criteria that you should remember. Now let's have a look at this particular pedigree, right? So if I look at this pedigree, what am I seeing the most? I do see that unaffected parents have affected offspring, right? So this is one thing that sometimes indicate about, I mentioned, the recessive nature of the pedigree, right? And same is happening here. Unaffected parents have this affected kid, right? Now also pay attention to the male and female ratios in this pedigree. Do you see equal number of male and female ratios, male and female offspring affected? No. You do see that the males are more prone for this disease. You see, more males are affected than females. So now you have a a better idea that this pedigree is going to fall into the sex-linked kind of inheritance pattern, because this is very critical point which is not seen in other type of pedigree. So more males are affected, that is what you are seeing, more males, right? And then if you see that if this male is affected, right, and if this is a Y-linked inheritance, we will discuss about the Y-linked inheritance in next slide itself, then but you already know that a male is a XY and a female is XX, right? So this one, a male always inherit Y chromosome from their father. So you can see that this Y, if the inheritance is because of this Y chromosome, then these males should be affected, right? But they are not. So we already rule out that this is not a Y-linked inheritance, right? So male inheritance we can clearly rule out, and the same thing you can see in the next generation, right? One more important thing that you clearly observe in this pedigree is that here this number 3 male is affected. And what I said, if it is a X-linked inheritance, then this X is going to the daughter for sure. Every time a daughter is going to receive one chromosome from the father, important point, right? Whereas in case of mother, you can never say if this X will go to the daughter or this X will go to the daughter. There are 50-50 chances, but 100% chances that the daughter is getting the X chromosome from father, right? So you can see that this male is affected, and you are absolutely sure if this is a X-linked recessive inheritance, this X is coming from the father, so this mother should be carrier, and you can clearly see all the sons of this mother are affected, right? All the sons of this mother are affected. That clearly shows that because this is a carrier, XR, what you would see, this X and the other X might be normal, then 50% of males will have chance to receive this X chromosome. That's why you see the 5 and 7 are affected, but the 8 is not. This 8 is getting the unaffected X chromosome, right? So this is an important thing. So the father is transferring the disease allele through her daughter to the grandchildren, right? So this parent, this one, the number 3 over here, is transferring through this daughter to these, through this 7th daughter to these two sons, right? And by identifying that, you can identify how many carriers are there in this pedigree. I would say you just mark them on your own. Okay, so this is the pedigree which is X-linked recessive. Now look at the Y-linked pedigree. What you would expect in a trait which is showing a Y-linked inheritance? Only males are affected. So one more thing, you get confused when you look at this pedigree because what you're seeing over here, all males are affected, right? But if you notice, you see what they have done is they have marked all the reds, the affected one as male. But in this pedigree, there are males that are not affected. You see that, right? So that will not be the case when you will look at the Y-linked pedigree. If a parent is affected, right, then always a male child will be affected. You can see that. So do pay attention to these points, because sometimes just by looking at this X-linked recessive pedigree, and if you're not judging every point critically, you might be confused and just say that, okay, it looks like a male Y-linked inheritance. So what are the other points that differentiate the Y-linked trait? So only the males are affected. It passes from father to all sons, right? No females are affected or career. It does not skip the generations. So this is something I would think, one of those easiest things that you can identify in a pedigree. As I just mentioned, you can see in the parents, father is affected. When the offsprings come, every single male child is affected and daughters are unaffected, right? And then if this male gets married, again the males are affected. If this male gets married, again the male is affected. And same is true for number 6 is affected, then all males are affected and daughters are not, right? So I have write these important points over here as well for your remembrance. So this is how we look at a Y-linked pedigree. So now the third category is the identification of a X-linked dominant trait in a pedigree. So again, I would say when you look at X-linked trait, first identify what discriminate X-linked inheritance pattern from the autosomal dominant inheritance pattern, right? So here this differentiating thing is that affected male pass all the trait to all daughters but no son. This is very important, very, very important point. That if a male is affected, right, and why that is happening? Because let's say this is the disease allele, right, and it is dominant in nature, right, and then let's say just you have a normal female and you have this XX and X, right. This will be the females and the males will be Y and X, whatever. I just consider mother as homozygous, right. So what you are seeing, this X, as I said, a daughter always receives a X chromosome from the father, and if father has a dominant disorder, the daughter is definitely going to have it. But sons will not, because it is not Y-linked and Y chromosome is normal. X they are receiving from their mother. So no son. All daughters, just the opposite. Here all sons, no daughter in case of Y-linked inheritance, and here all daughters, no son. And this kind of pattern you don't see in autosomal dominant. Autosomal dominance in dominant type of inheritance never show any bias towards the male or female offsprings, right? So just going one by one to each point, it affects both sex, but often more females, right? The trait does not skip generations, as we see in case of autosomal dominant as well. Heterozygous female may be less severely affected because definitely they have 2 X chromosome, and we will discuss it in another unit where we will be discussing about the bar body formation in case of one of the copy of X chromosome, and so the females having 2 X chromosome, only one is active, reduces their chance to show the disease more severely. So these are the characters that differentiate that you can use to differentiate a X-linked dominant trait in a pedigree. So now let's look at the pedigree, which is the X-linked dominant. So if you see that if this is an X-linked dominant pedigree, right, and then this is an affected male, right, and you see that all daughters are affected, so definitely they are receiving this XX and XX from father, right, and none of the sons they are not having any problem. So for now, I'm just putting one X like like that, and then this one like that, just to show that these are normal X chromosome, because it's a dominant disorder, and because it is a dominant thing, then if mother was having any dominant allele, you will see the effect. So it is a homozygous recessive female mother, right? And then this female, you see another X will be normal here. Then you see that the 50% chances of normal and affected males in this particular case, and the same is true for the female, because father is unaffected, right? You're not seeing any skipping of generation here. And here if you focus, because this allele is not present, it's dominant, and because parents are not having it to start with, none of the lineages having any disorder. It's a clean side of the pedigree, right? So what you need to pay attention to, that affected male pass straight to all daughters and no sons. Affected both sexes, it affects both sexes, but often more to female. So if you look at the pedigree, then you will see that number of affected female are 1, 2, 3, 4, 5. 1, 2, 3, 4. Well, in this pedigree, we can't really conclude that it is more affected, it is more affecting female compared to male, but by and large, it affects more female compared to a male. So, and it also not skipping the generation, which as I said, is very common in case of the dominant disorders. So, now I just want you to look at all these points together once more, that X-linked recessive, when we compare X-linked recessive, X-linked dominant and Y-linked disorder, we see that X-linked recessive disorder affect more males, and male to male transmission is mostly seen in case of Y-linked disorder, whereas X-linked disorders don't show any bias. All daughters are affected if father has it, right? It is the X-linked dominant, and because one X chromosome is from father, and if it is dominant, it will definitely show up. And it, in case of sons are not going to receive the dominant disorder anyways from father. So skipping the generation, if it is a dominant, then rarely, and if it is a recessive, often. So that is something which is common, but it is not a solid rule that you just focus on skipping on generation and not. So whenever my conclusion, I mean, repeated probably point that I'm telling you, that you need to focus on several parameters when you are looking at the pedigree. Just don't look at one or two things and conclude in hurry. At least I will more systematically show you how you should rule out different possibilities when you are looking at a pedigree in our next class. So in this class particularly, I'm leaving you with these two reasoning based questions that are shown on your screen. So read them carefully and then answer these questions in the chat box or your return reply to me. And in case you have any difficulty understanding what I have discussed so far, feel free to discuss your concerns or questions with me. See, this analysis of pedigree is something that you will learn by practicing. You need to do two major things. One, you have to remember these points, right? Every time when I'm showing a pedigree, I'm listing these points here, right? So all like these points. You need to remember these points. And then you have to practice the pedigree to see if you are able to apply these points to the pedigree or not. And if you would do that, then I'm very sure that it is not going to be any problem for you. So with that, I would like to thank you all for your attention and your time, and see you in the next class.